Okay, Assalamualaikum and very good morning to everyone. So welcome back to another video. So in this video, we're going to discuss a molecular geometry part 2 under subtopic 4.2 chemical bonding. Okay, chapter 4 chemical bonding. Okay, so by the end of this lesson, you should be able to predict and explain the shape of the molecule and also the bond angles in a given species. So from the previous video, awak dah belajar dah macam mana kita nak determine the different type of the molecular shape. And in this video, I'm going to teach you on how to explain, okay, when you want to answer question that related with molecular geometry. Okay, so we recall back, recall the Vesper theory. So Vesper's theory state that in order to minimize the repulsion, each group of the valence electron around the central atom is must be located as far as possible from the others. Okay, so we need to consider the repulsion lah between the electron group. So remember that the lone pair repulsion is a stronger repulsion compared to lone pair bonding pair. And lone pair bonding pair repulsion is stronger to the bonding pair and bonding pair repulsion. So we're going to use a Vesper theory when you want to explain how you obtain the molecular geometry or the molecular shape from the Lewis structure. Okay, when you want to explain the molecular geometry of the compound, there are few key points that you need to include in your answer. Okay, so the first step is you need to always start by drawing the Lewis structure. Okay, must always start by drawing the Lewis structure and then you need to draw the molecular shape. Okay, so the second step is after you draw the Lewis structure, then you need to state the number of electron pair. Okay, number of electron pair ni awak kena include sekali both bonding and also the non-bonding group. And when you state the number of electron pair, then you need to state the electron pair arrangement. So electron pair arrangement ada 5. So we have linear, trigonal planar, tetrahedral, trigonal bipyramidal, and also the last one is octahedral. So if you have 2 electron pair, the electron pair arrangement is linear. Kalau 3, trigonal planar. 4, tetrahedral. 5, trigonal bipyramidal. And 6, octahedral. Then after you state both the electron pair and also the electron pair arrangement, then you need to state the number of the bonding pair and also lone pair. Because the number of bonding pair and lone pair ni akan menentukan macam mana dia punya molecular shape. Okay, and then we need to state the strength of the repulsion. Yang ini yang saya cakap tadi. So lone pair repulsion is stronger than lone pair bonding pair, and lone pair bonding pair repulsion is stronger than bonding pair repulsion. Then after you state the strength of repulsion, kita kena state bonding pair arrangement dia ataupun dia punya molecular shape, and the last one we need to state the bond angle. So for the bond angle ni either awak state separately in the sentence or you can draw directly on your molecular shape. Okay, so the first example, okay, is CH4. Remember that the first step is you need to draw the Lewis structure. Okay, so CH4, okay, kalau awak draw Lewis structure, the carbon will become the central atom. Okay, and the hydrogen will become the terminal atom. So this is the Lewis structure for CH4 or methane. So if you look at the Lewis structure of the CH4, okay, the electron pair group, okay, ataupun the number of electron pair dia. So kita tengok So remember that one bond, okay, ataupun single bond dikira sebagai one electron pair. So we have 1, 2, 3, 4. Okay, number of electron pair is equals to 4. So when the number of electron pair is equal to 4, so the electron pair arrangement dia, so electron pair arrangement dia is equal to tetrahedral. Okay, then we need to state the number of bonding pair. Okay, kalau awak tengok number of bonding pair, we have 1, 2, 3, 4. So number of bonding pair equal to 4. Number of lone pair, Okay, kita tengok dekat central atom tak ada lone pair, so number of lone pair is 0. Okay, if you look at the Lewis structure, the repulsion itu hanya exist between bonding pair and bonding pair. Sebab kalau awak tengok the Lewis structure, around the central atom carbon ini does not have any lone pair. So that's why lah kita hanya perlu consider bonding pair, repulsion. Okay, so number of bonding pair 4, number of lone pair 0. So the molecular shape, okay, so the molecular shape dia, so kalau awak ada 4 bonding pair and 0 lone pair, the molecular shape is tetrahedral. Okay, so now kita dah boleh lukis dia punya molecular shape. So nak lukis tetrahedral, okay, awak lukis central atom. Okay, awak lukis satu atas. Okay, and then awak lukis satu hidrogen sini. Satu hidrogen tu berada berdekatan dan satu lagi awak jarakkan sikit. And awak either boleh terus tulis dia punya bond angle. Okay, the bond angle dia adalah 109.5, which is the ideal bond angle for a tetrahedral. So ini adalah dia punya molecular shape, dan ini adalah kita punya Lewis structure. So kalau awak tengok Lewis structure itu dia tak menunjukkan the actual shape of the molecule. So dah list down all the important information, dan kita boleh create dalam bentuk sentence. Okay, this is the example, okay, on how to explain the molecular shape of CH4. So awak ikut je tadi flow yang sebagi awal-awal tadi, awak ikut je key points itu. So okay, based on the Lewis structure, CH4 have 4 electron pair. So the electron pair arrangement is tetrahedral. Okay, so the CH4 have 4 bonding pair and 0 lone pair electron around the central atom. Okay, and according to Vesper, the repulsion between the bonding pair repulsion is the same. Sebab kalau awak tengok tadi Lewis structure tu, kita hanya ada bonding pair sahaja, tak ada lone pair. So that's why kita cakap bonding pair dia akan sama. So the molecular shape adalah tetrahedral, and the bond angle between each CH is a perfect bond angle for tetrahedral, which is 109.5. Okay, this is how you explain if the question asks you to determine the molecular shape of the molecule. Okay, let's go to the next example, NH3. Okay, the next example is NH3. So remember that the first one is you need to draw the Lewis structure. Okay, so NH3, the nitrogen will become the central atom. Okay, nitrogen becomes central atom, and then we have 3 hydrogen at the terminal. And if you draw the Lewis structure, awak akan nampak ada satu lone pair electron on the nitrogen. Okay, so kita state dia punya electron pair. So the number of electron pair, okay, kalau awak tengok single bond dikira sebagai satu group. Ini satu, dan lone pair, satu lone pair itu dikira sebagai satu. So total dia adalah 4. Okay, so maknanya the electron group arrangement dia, so kalau awak ada number of electron pair dia adalah sangat 4, the electron group arrangement is equal to tetrahedral. Okay, so and then kita determine number of bonding pair. So kalau awak tengok bonding pair 1, 2, 3. So the number of bonding pair is equal to 3. Number of lone pair is equal to 1. Ini kita punya lone pair. So kalau electron pair arrangement awak tetrahedral, okay, and then awak tengok number of bonding pair dia 3, number of lone pair dia 1. Okay, so kalau awak tengok dia punya molecular shape, okay, molecular shape dia adalah bersamaan dengan trigonal pyramidal. Okay, so bond angle dia akan lagi rendah daripada 109.5. Tapi for NH3 awak kena tahu dia punya actual bond angle. So the actual bond angle for NH3 is 107.3. Okay, so nanti ini adalah Lewis structure. Okay, and then kita akan convertkan dia kepada dia punya molecular geometry for trigonal pyramidal. For trigonal pyramidal. So we have nitrogen, we have hydrogen here. Okay, so this is the lone pair. So this is the molecular geometry and the bond angle is 107.3 degree. So nak explain sama juga macam yang saya terangkan tadi. So ikut sahaja flow. Ikut saja flow key point yang sebagai awal tadi. So NH3 have 4 electron pair. So the electron pair arrangement for NH3 is tetrahedral. So NH3 have 3 bonding pair. Okay, and 1 lone pair. Okay, around the central atom. So kalau awak tengok molecular shape ataupun Lewis structure tadi, awak tengok kita akan ada repulsion between lone pair and repulsion between lone pair and bonding pair. So according to Vesper theory, the repulsion between lone pair is stronger than lone pair bonding pair, and lone pair bonding pair is stronger compared to bonding pair. So angle perfect angle tetrahedral tu asalnya 109.5. Since sebab kita ada satu lone pair, dia akan reduce. So dia akan jadi 107.3 and the shape is trigonal pyramidal. Okay. So the next example is water. So if you draw the Lewis structure of water, the oxygen will become the central atom. Okay, and then hydrogen will become terminal, and then you have two lone pair around the central atom. Okay, so macam biasa kita ikut flow tadi. So number of electron pair. So kalau awak tengok structure ini, kita ada 2 bonding pair and 2 lone pair. So total dia adalah bersamaan dengan 4. So electron group arrangement dia, so kalau awak ada 4, so electron group arrangement it will going to be tetrahedral. Okay. So number of bonding pair. So kalau awak tengok bonding pair dia, number of bonding pair sama dengan 2. Number of lone pair is also equals to 2. Okay, so kalau awak tengok Lewis structure ni, kita dah ada lone pair and lone dengan bonding pair. So maknanya lone pair repulsion is stronger than the lone pair bonding pair and stronger than bonding pair. So kalau awak electron group arrangement awak lah tetrahedral, okay, dan awak ada 2 bonding pair and 2 lone pair. So maknanya the shape adalah V shape ataupun band. So oksigen, hidrogen dan satu pair elektron sini, satu pair elektron dekat sini. So ini adalah dia punya molecular geometry. Kita panggil sebagai V shape ataupun kita panggil dia sebagai band. Okay. So dan angle dia sebab dia ada lagi banyak lone pair daripada amonia, so angle dia akan lagi rendah daripada 107.3. So the angle dia, the actual angle is 104.5 degree. So awak boleh tulis bond angle tu dalam ayat ataupun awak boleh tulis bond angle tu dekat dalam awak punya drawing molecular geometry itu. So nak terangkan pun sama yang macam saya terangkan tadi. So water has 4 electron pair. So electron pair arrangement dia adalah tetrahedral, and water have 2 bonding pair and 2 lone pair around the central atom. And according to Vesper theory, the repulsion between the lone pair is greater than lone pair bonding pair, and the repulsion between lone pair bonding pair is greater than bonding pair. So the molecular shape for water is V shape ataupun band, and the each H or H angle, in this one should be water. Okay, water is 104.5. Okay, we look at the last example, XeF4, okay, or xenon tetrafluoride. So, kalau awak draw dia punya Lewis structure, the xenon will become the central atom. Okay, and then we have 4 fluorine. Okay, 4 fluorine and then 2 lone pair on the central atom. Okay, so number of electron group. Okay, kalau awak tengok Lewis structure tu ada 4 bonding pair and then 2 lone pair. So 4 plus 2 equals to 6. So the electron group arrangement, okay, so if you have 6 number of electron pair, so the electron group arrangement dia akan jadi octahedral. Okay. So number of bonding pair dia adalah, awak tengok agak ada sama 4 dan number of lone pair dia bersamaan dengan 2. So if you look at the Lewis structure, the lone pair repulsion is stronger than lone pair bonding pair. And then lone pair bonding pair repulsion is stronger than the bonding pair repulsion. Okay, so dia punya shape dia adalah, so kalau awak ada 4 bonding pair and then 2 lone pair, the shape is a square planar. So square planar, XE akan jadi central. Okay, and then awak ada fluorine sebagai terminal atom. Okay, remember that in square planar, the 2 lone pair itu mesti berada berjauhan in order to minimize repulsion. That's why kita akan lukis satu pair dekat atas dan satu pair dekat bawah. And then the bond angle between FXEF ini is equal to 90 degree. Bond angle for square planar is equal to 90 degree. So kalau Lewis structure, okay, kalau Lewis structure dekat terminal atom itu awak akan lukis lone pair. Tapi untuk molecular geometry awak tak perlu, tak diwajibkan untuk lukis lone pair on the terminal. Tapi lone pair on the central atom wajib lukis. Yang tak perlu lukis hanyalah lone pair on the terminal atom. Dan ini hanya apabila soalan minta awak draw the molecular geometry sahaja. Tapi kalau the question ask you to draw the Lewis structure, dan awak kena lukis macam biasa. Okay. So nak explain pun sama macam tadi. So kita explain macam yang saya ajar awal-awal. Ikut je sahaja flow key points itu. So xenon tetrafluoride has 6 electron pair. So the electron pair arrangement, this one should be octahedral. Okay, octahedral. So there are the 4 bonding pair and 2 lone pair. And then according to the Vesper theory, the repulsion between lone pair greater than lone pair bonding pair and greater than bonding pair. So the molecular shape is square planar and the angle between fluorine, xenon and fluorine is 90 degree. Okay, so that's all for today's video. Okay, and on the next lesson, okay, we're going to learn how the molecular geometry will affect the molecular polarity of the